Hello, welcome to my channel. I'm very happy to be here with all of you. And today, if you hear about the PNP sensor or maybe NPN sensor, so what is it? And have you ever heard about the application that they will use in the factory? So this video today, I will tell you more. So the first about the NPN or PNP. So right here on my hand, I just have the PNP actually. This is the inductive sensor. This detect the metal near it. So in the catalog, right here we have the 5mm, maybe the distance right here. So if the metal right on my hand, and then I will move near maybe the surface of this sensor, I mean inductive sensor, and then they will have the signal. So have you ever thought about the principle of this? So I have the principle on the board, but today I don't talk more detail about the principle of this, but I will tell you the real application when you have the equipment on your hand and how to install this equipment very easily. It's like you brush your teeth every morning, of course. And right now, I don't spend a lot of time to talk a lot, but right now, I will connect to the demonstration. So on the table, can you see it? I have the demonstration right here. So on the right, on my left hand, or maybe on your screen, you can see right here. This is the light, and this is maybe emergency light and the beacon. And right here, we have the smart I/O right here. So the smart I/O here, I set up it in output. It will control the relay, and then relay control the light right here. But what about the control? Where can I control this system? This maybe output right here. So I need to the smart I/O. I mean the digital, the DI. The DI is just the contact like this. Have you ever talked this button? Maybe in your country or maybe this kind of the contact. Just usually. This normally open and then you change the stator, then it's normally closed, and then your circuit is shorted. And right now, this is the DI. So about the DI side, I have the PNP sensor. So the PNP sensor right here is the mixture from the bailiff. The bailiff, I mean. So when you want to discover, when you want to find more information about this, they have the information on the surface of the sensor right here. So they will have the code, the model right here, so you can search on the internet about the data sheet. So about the data sheet, I have to tell you 3 points. The first, this is NPN, this is BNP. And the second, the voltage is from the 12 to 30 VDC. VDC is a volt DC, I mean, and the maximum, the rated operating distance is nearly 5mm. About the normally open, what is it? So when you have the signal, talk again, have the signal right here, you will receive. You will out, this sensor you will out, the positive 34 VDC. So I will tell you right now. The first, I have the cable like this, so okay, 1 point I would like to tell you right here. So about the sensor. So you can see this is the diagram. So about the diagram there, this is the side, the connector. So right here you can see the diagram connector like drawings. You can see then the wiring number 1, number 2, 3, 4. So about the wiring, we just use 3 connector, 1, 4, and 3. So about the one is the power supply, the positive 34 VDC. And about number 3 is the negative. So every sensor, we need supply the voltage DC for them to use, of course. And what about the output? So this is PNP output. PNP, that means you use the positive point. So right here, we have the number 4 wiring right here. Number 4 is the normally open. So when you have the signal right here, signal, no signal. The distance is nearly 5 millimeter. Signal, have signal. And they will get the output right here, the positive of 34 VDC right here. So a little bit square, I mean right here is, can you see? Oh sorry. Okay, right here. I have the bigger diagram right here. This is the metal. And when you move closely to the sensor, this is the sensor. This is the sensor. And this is the metal. So when you move the metal near the sensor, and then this is the normally open. When they get a signal, they will closely. So normally open to normally close. And then they will send the output right here is positive. This is the positive. And normally the line you connect currently, you connect the negative before, and then when you get the when you get the positive, then the light be bright, then you will get a signal out there. Okay, and then don't take a lot of time for you. So near 5 millimeter, you can see there will be the light right here, maybe the orange light, and you will get the output right there. Okay, move out of 5 millimeter, there's no signal. Okay, so come back to the diagram right now. So on the board, so I would like to explain more. So this is the load. This is the load, and for your more detail, okay, I will use the pen right here. So you understand? So this is the sensor, and this is smart diode, DI. Okay, and you can check the wiring right there. So this is the PNP I'm using to inductive sensor. Inductive sensor. Inductive. Yes, of course. And right now we have the metal right here. So sorry about my mother language is not English. So, and right now I have the PNP. This is normally open. And right here, when we move the metal nearly 5 millimeter, around 5 millimeter, or maybe next to the surface of the sensor right here, from normally open, they will normally close. And right here, this is last time before I explained, this is number 1 wiring connector. This is number 3, and this is number 4. Okay. And when you get a signal, when we get a signal right here, and then it will turn the stator from the normally open to normally closed, and then 24 volt right here, they move to this side, and then output right here is 24 VDC. And right here about the DI of smart IO, maybe POC or maybe smart IO, Okay, right here input, right here we have the positive thing. Right now, if we have the signal, if we, put the metal next to the sensor, we got the positive of 34 volt VDC. And before, of course, we connect to the negative before. And when we get a signal, maybe right here, maybe if you, of course, if you have the relay right here, if relay. This is the relay, and then you have the output, and then from this relay you can control the line the diagram below, because this for my demonstration, this side is DI, and by the lane, this side by DI, by the lane I connect to another DO, smart IO right here. I control the line through the relay. This is the diagram. So don't think about that. Just focus on the relay right here. So if you get a signal right here, normally you have no signal right here if you don't move the metal near the surface of PNP sensor, I mean the inductive sensor. So if you get a signal, then you will get the coil will be turned the state, and then you can control anything, maybe the 20 VAC or maybe the 3-phase, okay, VAC, and okay. So it's really easy for this, this diagram. So I hope you understand this, this explanation. So about this one, so I think you have a chance to see before in your university or maybe on the internet. But I don't want to go detail about this. So just look around. And for PNP, I tell input right here is the positive. Provide the positive for this sense for the output. So right here we have the load. The load right here is the same with the load right there, right here I mean. So normally there is no current, there is no positive point right here. Normally you connect the negative first. You always connect the negative first for the PNP. And when you get a signal, they will open the relay, maybe right here, the relay, or maybe you depend on your choosing the output. I mean, this is just the key, okay? So don't take a look about this. I would like to see this diagram more. So I think this diagram is really useful for you, maybe in the future, or maybe if you need to find more information about this. So you can get a lot of information about this diagram. So if you have more information, just tell me and comment below, and I will willing to answer your question. So if you like this video, just subscribe the button, like the video, and then in the future you will receive more video. Thank you and see you next time.